Okay, term 1, week 2, physics CA. Welcome to your first physics CA of the year. It's 1.1 to 1.4. As usual, I will go through my notes, and then we'll go through the quiz, then we'll solve the grids, and I will include timestamps for all physics and mechanics videos, so you should be able to go in the description and see time. You can just click on the time. For example, wait, let me show you. So if you look here in the mechanics video, if you hover over, you can see, here it's quiz, and then here it's grids, and then over here it's quiz, and then here it's notes. So you can either look at the timestamps in the description, or you could just scroll through. See, here it's notes, and then changes to quiz. So anyways, oh, that's loud. uh let's start. Let's start with the notes. It's all about temperature. There's a lot of memorizing, and it's good. I took down notes, so the important things that may not be in the quiz will be in the notes. Okay, what is temperature? The temperature is defined as, oh, where's my open board? Temperature is defined as the degree of hotness of a body. Okay, it can be changed and it can be measured. Okay, temperature can change and you can also measure temperature. Okay, a physical change is any change that takes place at the same temperature and pressure. It takes place anywhere at any time, blah, 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 blah. This is not important, but good to know. Okay, this is important. A thermometric property. What is a thermometric property? It's any property that can be changed and measured. Why do we need thermometric properties? We use them to make thermometers. Okay. For example, in this question here, is it thermometric or not? The whiteness of an egg, is it a thermometric property? No, you can't measure how white an egg is. وكمان, when you cook the egg, you can't change it back to a raw egg. So you can't change it, okay? Length of mercury, if you put mercury inside a glass, if you put mercury inside a glass and you change the temperature, the length of the mercury can start going up and down, okay, depending on how high the temperature is. It can go up and it can go back down. That's what makes it thermometric. But the egg white, when you cook it, it can't go back. You know what I mean? So that's why the length of mercury is thermometric. I'll talk about it in a bit more. The length of mercury. The mass of a fixed quantity of gas, is it thermometric? No, because it stays constant. The mass of any fixed quantity of any gas is always constant. Thermometers. Okay, we have 4 types of thermometers. We have the mercury in glass, we have alcohol in glass, we have the thermocouple, and we have the bimetallic strip. Here I drew a table for the thermometer and what thermometric property each thermometer has. For the mercury in glass, it's the length of the mercury column. Same thing with alcohol in glass, it's the length of the alcohol column. Because at certain temperatures, the mercury will start to rise and then go down. Like, for example, over here, let's say this is the length of the mercury, it's at 40. But over here at 50, when you raise the temperature to 50, it went up, the mercury. You get what I mean? Same thing with alcohol. And then for the pictures, I don't know if they ask it in the quiz, but if you ever see the pictures, the mercury in glass doesn't have a color, but alcohol in glass has a color. I'll show you the book in a bit. Wait, let me explain this. The thermocouple, it's electric current in case they ask it, and then the bimetallic strip, bimetallic strip is the length of the metal strip. Sometimes on bridges, okay, or like in Dubai, مثلا, on the bridges in Dubai, it's made out of bimetallic strips. So in the summer, when it gets hot, the bimetallic the strip it's made out of actually extends and lengthens. But when it gets cold again, the strip shrinks and shortens back. Okay, so just for you guys to know, this is very important information. Now I'll open the pictures for you. Wait. Okay, yeah. For over here, let me just zoom in. Can I go? Oh, okay. I can't. Okay. Over here at the bottom, you have, this is the mercury because it doesn't have a color. Okay. This is the alcohol because it's red. Okay. This is the thermocouple because it's a couple of positive and negative. وهيدي is the bimetallic strip. Okay. In case they ask it in the exam, no, drag and drop the picture or whatever. Okay. To measure temperature, you need a scale and you need a unit on your thermometer, right? So we devised an experiment for anybody to make their own thermometer. How? There are 2 things you need to know: the ice point and the steam point. Okay, we know that water freezes, right? It freezes at 0 degrees Celsius. And we know it boils at 100 degrees Celsius. So immediately you can know that if you take a thermometer, let's say it has alcohol in it. I'm going to use a different color for the thermometer. Let's say blue, okay? Blue thermometer. Let's say I put it hella, I'm going to use the book for this because it's better. Let's say I put this glass, it has mercury inside it, okay? And I put it in melting ice, okay? You know that ice melts, okay, at 0 degrees Celsius. So you know that the level of the thermometer or this glass, when I put it in the ice, actually is going to be 0 degrees Celsius because it's a known fact that ice melts at 0 degrees Celsius. Okay, so when you get that, now you're going to mark on your glass, you're going to mark the level of mercury. You can say, oh, it's 0 degrees Celsius. So, okay, now, and I need another point. What else do we know about water? We know that it boils at 100 degrees Celsius. So you can take it to a glass that's boiling water, and you can put it inside, and the liquid inside the glass will rise, and we know it's going to rise to how much? To, of course, 100 degrees Celsius. So you would take it and you'd mark it 100 degrees Celsius. We already marked the 0 degrees Celsius from before, so now easily we can put it in anywhere and we can just find the distance between them and we can calculate it. So, a few things you need to take note of. Okay, calibrate the thermometer. I'll go to the calibration in a second. But first, let me start here. The ice point is 0 degrees Celsius. Where do you place your glass? You place it with the melting ice, not on top of, you place it with melting ice. The physics regional likes to play with the words, okay? He will catch you off guard. He does it a lot, okay? So make sure it's with melting ice, not frozen ice, okay? No. We want melting ice, melting ice. Other people also say crushed ice. These two words are correct, okay? The steam point. The steam point, we know it's when it boils, right? Place the thermometer, above boiling water, not inside. In the ILS exercises, they put inside and it was false. It was wrong, okay? Make sure you place it above the boiling water, okay? So, in the book here, they showed you, did they place the thermometer with the steam or inside the boiling water? They place it with the steam. So, with the steam is the same as above the boiling water, okay? What are the hazards? You need to know these. They don't ask them in detail, but they ask which of the following which you have to pay attention to when calibrating a thermometer. There are three things. You have to know that the glass is fragile, so if you drop it, it might break or you might cut someone. A cut thermometer, by the way, is very deadly. You can easily kill someone with the glass. The mercury inside the glass is very toxic. If it gets on your fingers, it will burn your fingers. It will kill your skin cells. And the heat. We're boiling water, so make sure please, if you're doing this experiment, not to burn yourself, okay? Because steam burns skin more than hot water. It's more deadly. To calibrate a thermometer, here's what you do. So the first thing you do is you find the steam and ice point. I meant ice. I don't know why I put gas. The steam and ice point. When you find the steam and ice point, you mark them, right? So you call L0 the length for the ice point. So this is my thermometer here, and I mark down 0 degrees Celsius. Let me use red now. I mark down 0 degrees Celsius, and I'm going to mark the length from the bottom to 0 degrees Celsius. We call it L0. Then you're going to do the same thing, but for the steam point. The steam point is higher. It's up here, right? So we're going to call the distance from the bottom up until the steam point L100. Okay, so we have L0 and L100 for the ice point and steam point. We marked it. Okay, now you take a graph. Okay, you're going to take a graph like this. You have your X and the Y. They said on the X, you're going to plot the length in meters. Okay, and on top, you're going to plot theta in degrees Celsius. Theta, any temperature. Okay, what are you going to do? We know that L0 is somewhere over here. Okay, and at length 0, it's 0 degrees Celsius, the temperature. And we know at L100, okay, its temperature at L100 is 100 degrees Celsius. What do? You connect a line, okay, and now you can measure the length of mercury anytime and just put it in here. So let's say now I have my graph, right? Let's say I I take my glass, I put it in, I don't know, it gives me here. Okay, I'd measure the length from the bottom to here. I want to know how much is the temperature here. I measure the length from the bottom to here. Then I take that length and I put it in my graph. Let's say it's over here. I'd go up, see how much is the temperature. Let's say it's about 75 because it's in between. It's almost 100, but it's not 50. This is how you do it. I know it's a bit confusing, but it's just these steps that you have to memorize. First, find the steam and ice point, not gas point. Steam and ice point. L0 is the length for the ice point. L100 is for the steam point. Okay. Then you graph and plot it. Down you have length in meters, in centimeters, and then up you have degrees Celsius. Then you measure any object. Okay, we're done with the boring stuff. Now it's a bit into the formulas. This is where it gets a bit interesting. Boyle's law. We all know what Boyle's law is. Boyle's law states for the same amount of gas, the product of pressure that the gas exerts by the volume is the same for all ideal gases at equal temperatures. Okay, so at T constant, there are many ways the regional can ask the question. Okay, and he's done it like this many times before. Okay, here's what he does. At equal temperatures, he would ask like this. He would say at T constant, and he's going to give you multiple choice. You have to select which one's true. P times V equals constant. Yes. P1V1 equals P2V2. Yes, because we know the product is equal. So they're directly proportional. So PV equals constant. P1V, not PV, the inverse proportion. Forget about the directly proportional. PV is equal to a constant, so it's always constant. The product is always constant. P1V1 equals P2V2. I'm sure you all know it. V is directly proportional to 1 over P. This is the same, and I drew it wrong. V is directly proportional to 1 over P. Okay, and also it's the same for the other way around. P is directly proportional to 1 over V. Okay, so if you were to draw a graph for V and 1 over P, they would be directly proportional, so it would be a straight line passing through the origin, right? Remember, when anything is directly proportional, it's always a straight line passing through the origin. And then over here, V and P, they're inversely proportional. This means V and P are inversely proportional. When you have 1 over something, it means they're inversely proportional. Okay, so V and P, since it's inversely proportional, it's going to be going down. Okay, in case you get any of these choices here, just memorize صراحة, and there's nothing really you can understand. It's a theorem, it's a law, so you have to memorize it. Okay, forget about this. Okay, Kelvin, yeah. You know how to convert from Celsius to Kelvin. You add 273.15, but usually while solving we ignore the 0.15. Okay, absolute zero is when temperature is 0 Kelvin, right? And it's the absolute temperature of an ideal gas. These are just notes I have. Okay, the thermocouple. The thermocouple is made out of 2 metals, iron and copper. Okay, it has 2 junctions. Okay, there's a reference thermojunction and then there's a probe. The reference thermojunction is the one that stays constant. Okay, so let's say it starts at T equals 20, it's going to stay at T equals 20. Okay, then the probe is the one that actually changes. Then in the middle you have a galvanometer. I'm going to show you how this looks like over here. Okay, this is a thermocouple. It's very important to know how it looks like because in the exam they might give you drag and drop, okay, to label it. This is the thermocouple. It's made out of the top wire W and wire Y. You have to know that wire W and wire Y, they're the same material, but wire Z is different because it's on the other side. Okay, wire Z is made out of a different metal. Okay, one of them is iron, one of them is copper. It's not really important which one is which, but you have to know one is iron, one is copper. Okay, then like I said, you have the 2 junctions. This is the cold junction is the reference junction, so this one's the one that stays constant, and then the hot junction is the probe, so this one's actually changing. It might be the other way around, it doesn't matter, but you have to know one of them is the reference junction, one of them is the probe. Probe means changes. Then you have at the top galvanometer. A galvanometer is that which measures electric current. Okay, it has many advantages to use a thermocouple. What are the 3 advantages? Very, very important. They will ask which of the following are the benefits of using a thermocouple. It comes in every CA, every periodic. أول شيء, it's high precision. It's very precise. So very, very precise to the nearest 0.01 Kelvin. Okay, it's very sensitive. So any small change will allow it to change, and any small change in the temperature will change the value, will change the reading you have. So it's very sensitive. So even it goes down to 4 Kelvin and it goes up to 2700 Kelvin. Okay, remember the thermocouple is a type of thermometer to measure temperature. Also, it has a very low heat capacity. Low heat capacity means يعني ما بتتحمل. In English, how can I say it? I'm trying to think of the word in English. بس ما بتتحمل يعني it can't stand not changing, so it has to change. It can't like يا أخي, how can I say it? Just know that it quickly fluctuates, okay? So it doesn't wait for a big change in temperature to change. So even to the, like I said, to the near 0.01 Kelvin, it will change. So all these three are pretty similar to each other, but it's very important to know all three, okay? These are the three advantages. They will ask it. Charles law. Now خلصنا من Boyle. Okay, هلا Charles. For a fixed amount of gas at a fixed pressure, okay, so pressure is constant. When we say fixed pressure, يعني pressure is constant. That's Boyle's law. The volume of a gas is directly proportional to its absolute temperature. Absolute temperature يعني شو temperature Kelvin ولا Celsius؟ أكيد Kelvin. Okay, so how can they ask this in the exam? The first thing they say, when P equals constant, and they tell you select all that applies. Volume is directly proportional to capital T. It has to be capital T. Has to be capital. Small t is time, not temperature. It has to be a big T for it to be counted as temperature. V is directly proportional to big T. Okay, so if you were to draw it in a graph, it would be a straight line passing through the origin. Okay, also you can say when P is constant, V over T is equal to constant. We also have V1 over T1 is equal to V2 over T2. These all are the same exact thing. The first, how I like to memorize is like this. And I know volume is directly proportional to temperature. That means V equals KT. So volume equals something times the temperature. Okay, if V equals KT, like which is written here, that means if you take T to the other side, V over T is equal to that K, constant, right? K means constant, guys. So there you go. I got the third one. Now I can show you the fourth one. If V over T is equal to that constant, that means the other V over T is also equal to that constant. So since they're both equal to that constant, V1 over T1 is equal to V2 over T2. Like this. And then obviously the straight line passing through the origin, that's self-explanatory. If two things are directly proportional, everybody should know that its graph would be a straight line passing through the origin. Oh, okay. This is nothing here, but the pressure law, I don't know why the camera here was messed up. This is an exercise, doesn't matter. But the pressure law. For a fixed amount of gas occupying a constant volume, هلا volume is constant. What happens? The pressure, when volume is constant, pressure is directly proportional to the absolute temperature. So P is directly proportional to T. So what does that mean? P equals KT, right? Okay, so if I take T to the other side, what does that mean? P over T is equal to that K. K means constant, guys. Also, what does that mean? If it's equal to the constant, that means any P over T is equal to that constant. That means all the P over T's are equal to each other. So P1 over T1 equals P2 over T2 equals P3 over P3 equals P4 over T4, and so on and so forth. And since it's directly proportional, أكيد it will be a straight line passing through the origin. They don't really care about this dotted part, but you're supposed to dot it because there's no way pressure can be equal to zero. That it doesn't work. So that's why we put a dotted line at the start. But that doesn't matter. You don't really ask that. But as long as you put it as a straight line passing through the origin, that's correct. But if they do give it in the exam with one that's dotted, one that's solid, make sure to pick the dotted line. Okay. The gas equation. Okay. خلصنا هلا. So far we had Boyle's law. Boyle's law, P1 V1 equals P2 V2. Right? Let's go back, revise quickly. Boyle's law, P1 V1 equals P2 V2. Or you could say that PV equals a constant. Okay, when is this? Remember, we have three cases. نحن in physics, we look at the pressure, temperature, and volume. If pressure times volume equals constant, that means the temperature is constant. Okay, what if... Or I'm going to show you an easier way now. I'll show you. Let me do the gas law, and I can explain to you the easy way. PV over T equals constant. Okay, that's what the gas equation is. This is the same as saying if PV equals T is equal to that constant, that means all PVs over T's are equal to that constant. So P1 over V1, P1 V1 over T1 equal to P2 V2 over T2. So you're going to tell me, okay, Walid, and I don't want to memorize Boyle's law, Charles' law, pressure law. صعب علي. Okay, it's hard. What can I do? Okay, you can memorize PV over T. Know this, PV over T. If temperature is constant, you put your hand, you cover temperature. What do I have left? PV equals constant. Okay, let's say PV over T again. Let's say volume is constant. What do I have? P over T equals constant. P over T equals constant. So that means P1 over T1 equals P2 over T2 when the volume is constant, right? Okay, so what if they say pressure is constant, PV over T? Pressure is constant, بتغطي على pressure, you put your hand over pressure, you cover it, you're left with V1 over T1 equals V2 over T2. These are the laws. So let's see. When pressure is constant, that would be, I think, Charles' law. See, come on, I forget. Charles' law, I think, is when pressure is constant. Yeah. Okay, we know that the volume is directly proportional to its absolute temperature. Then Boyle's law was when temperature is constant, so PV equals constant, right? Then the last one was, what was his name? Pressure law. Yeah, pressure law. So when this is when the volume is constant, the pressure and temperature P over T. Okay, so the easiest way to memorize it is using the gas law. Just cover anyone that's constant. PV over T, temperature constant, cover it, you get PV equals constant. Volume constant, cover it, P over T equals constant. And then into when you know P over T equals constant, it's the same as saying P equals the constant, let's just say K, okay? KT. So when you have anything P, A equals KB, anytime you see this K, that means they're directly proportional. So if you were to draw it like this, T, B, it will be a straight line passing through the origin. Remember, it's dotted at the start, yeah? هلا okay, these are all exercises. Anything important here? Okay, here's just drawing a thermocouple. We went over it earlier. Okay, this is the last thing. The average kinetic energy. Okay, we should know that the average kinetic energy is directly proportional to the absolute temperature. So it's written as E average equals KT. Okay, E average is the average kinetic energy. This dash means average. Okay, E is the kinetic energy, so average kinetic energy equals K, which is the constant, times T, which is absolute temperature in Kelvin. It has to be absolute temperature, guys. So, in other words, if temperature increases, then the kinetic energy increases. If energy is transferred to a body, then what will happen? Temperature will increase, right? You guys know. If أنا مثلا, let's say, until you're standing, okay? This is you. Or inte, well, if you're a girl or a boy. And then you have this box, okay? And you come, and for some reason, you just decide to, you slap the box, okay? You transferred energy, right? By the way, if you slap the box so hard, let's say you slap it so hard, and then you take your other hand, and then let's say you're not sore, theoretically, you take your other hand, and then you put it on where you slapped the box, you're gonna feel some heat, right? You're gonna feel some heat. Because you transferred energy to the box, and it's transferred in the form of, sorry, when you transfer energy, it changes to kinetic energy, and then the temperature increases, right? So when you transfer energy, you should know the temperature increases. And you know what temperature increases? That means heat increases. نفس الشيء. I kind of said it in a bad way, but you get my point. When you transfer energy, مثلا when you slap something or hit something, or in general, any energy transfer, it increases the temperature of the body you transferred energy to. Okay? This is activity. Okay. Know this. I'm not sure if this is included for this week or next week. Heat is internal energy. Is it internal, external? Akid internal. You feel heat inside of you, not outside of you. Heat is internal energy, but temperature is a measure of the average kinetic energy due to the random motion of the molecules. Heat energy is needed to raise the temperature, right? So, مثلا, when we take the same example of me hitting the box, right? Me hitting the box, you hit it, right? You hit it, and it transfers it into heat energy, okay? And when that heat energy rises, then what happens? It raises the temperature. And when you add heat, that temperature increases. And then when temperature increases, what happens to the average kinetic energy? Akid kinetic energy will increase. Okay, we're done. Hala, let's do the quiz. Okay, one thing I forgot to mention is hotness. Okay, up here when we're talking about temperature is the degree of hotness. When 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 do you feel hotness? Okay, when energy flows inside the body. When heat enters the body, you feel hotness. But when heat leaves the body, you feel coldness. It wasn't in my notes, but I forgot to mention it. I just realized now. Okay, hello now for the quiz. Uh, so before going into the quiz, uh, for some reason they're asking about the names of each law. Okay, and I guess you do have to memorize the names of each law. But just memorize the name. Let's do it like this. I'll try and get you a way to memorize them. Wait. Okay, let's start when temperature is constant, it's Boyle's law, right? Temperature constant, you cover it, you have P1, V1 equals P2, V2, right? It's Boyle's law. If you want a way to memorize it, what boil? Boil, let's think of it as the word boil as in B-O-I-L. To boil something. What happens when you boil something? Temperature, right? Boiling has to do with the temperature. So whenever temperature is constant, what happens when temperature changes? It's the Boyle's law. Okay, and it's spelled with a Y. Okay, then with Charles' law is when the pressure is constant. So PV over T, pressure is constant. Yeah, just memorize it, I guess. Wallah, just memorize it. Okay, because the third law is called the pressure law. And the pressure law, and I memorized it. Pressure law, yani pressure changes. Okay, pressure changes. And it's when volume is constant. Yeah, pressure law, and I know that pressure changes, and I know that volume is constant. Okay, هيك أنا memorize it. Pressure law, pressure changes. P changes. Okay, and then the last one that's left is just Charles' law. So we had PV, we had P changes. The only thing left now is V changes, right? The only thing left is when volume changes. And when volume changes, that's when pressure is constant. So when P is constant, it's not the pressure law, because we know when P is we know that the pressure law is when P changes, not when P is constant. So when P is constant, it's Charles' law. So memorize. Temperature constant, it has to do with boiling, so that's Boyle's law. Okay. When V is constant, when P is constant, it's not the pressure law. So what is it? It's the Charles law. Okay, try and find your own ways to memorize, and I gave you my way of memorizing now. Tamara placed her hands in cold water for a couple of seconds. She then takes them and places them in warm water. What is the sensation that Tamara feels? Akid, hotness, when she places it in warm water. The sensation of hotness is the sensation of when feeling cold, feeling hot. Okay, which of the following are true about hotness? A person experiences a sensation of hotness when heat flows into their hands. True. Do they experience a sensation of coldness when heat flows into their hands? Akid, no. When heat flows inside of them, that means they're gaining heat. That means akid they're going to feel hotness. Temperature is the degree of hotness of a body. It's the first note I have written down. Up here. Temperature is the degree of hotness of a body. Okay. The sense of hotness can be used to actually accurately measure the temperature. The sense of hotness or the degree of hotness? The degree of hotness, not the sense. Like I told you, the physics region likes to play with the words. The sensation of hotness is a quantity that can be measured. Can you measure the sensation, the feeling? Can you measure it? You can't measure the feeling of something, right? It's a sensation. It's a sense. Question 3, what are the hazards of calibrating a thermometer? We went over these. Remember that it's very hot because you're boiling water and measuring the temperature of that hot water. So the extreme heat. And the fragile glassware, because it's the glass thermometer, so it might break. And toxic mercury. Mercury is very toxic. Question 4, on the Celsius scale, the ice point is equal to 0 degrees Celsius and the steam point is 100 degrees Celsius. And both are defined for the atmospheric pressure of 100 kPa. This is just a quantity you have to memorize. You have to memorize that atmospheric pressure is 100 kilopascals. Okay, in case they bring it, but maybe they don't bring it. But always remember, atmospheric pressure is 100 kPa. 5. Okay. They're calibrating a thermometer here using the Celsius scale. We need 2 fixed points. What's the one on the lower part of the thermometer? Akid, the one on the lower part will be the ice point. How much is the ice point? We know it's 0 degrees. Okay, how do we reach the ice point? We place it in melting ice, right? Okay, how about the upper point? We know the upper point is called the steam point. And then the temperature of the upper point, we know it's 100. Okay, and how do we get the upper point? We get the upper point by placing it above boiling water. Remember, above boiling water, not in boiling water, above boiling water. So it will be in contact with the steam and not the water. Above. Very, very important. Again, you will always see the physics region will try to play with the words, okay? Make sure if they give you which of the following is true about calibrating a thermometer, and he puts to find the steam point, place it in boiling water, akid you will not pick it. It has to be above boiling water, okay? The absolute temperature of a gas at 150 degrees Celsius, they gave you two correct answers. Remember, to convert from Celsius to Kelvin, you do plus 273.15. That's the correct way to do it, okay? So you can do 423 or 423.15. Both answers are fine, okay? It doesn't matter. You can use any in the exam. They will give you both correct. Here, a thermometer is fixed above boiling water, inside a glass container. Okay, at a pressure of 1 atmosphere, blah, blah, blah. Okay, once the thermometer is in thermal equilibrium, equilibrium means it's the same temperature. Thermal equilibrium with the steam, so it has the same temperature as the steam. What will the reading be? Akid, it will be 100 because the steam we know is 100. Okay, and what do we call this point? It's called the steam point. Question 8. For a fixed mass of ideal gas, the relation P between the pressure P and the volume V at a constant temperature is called what's law? Boyle's law. Why? Because remember, when temperature is constant, what has to do with temperature? Remember, you boil, right? Boil. So Boyle's law. So, okay. And what's the law? Is it P times T equals K? No. Remember, PV over T. Cover temperature. What are you left with? PV equals constant. Okay, constant K. Okay. TV equals K, all these are wrong. The only one is PV equals K. 9. The relation between the absolute scale T and the Celsius scale theta is presented as temperature in Kelvin is equal to theta, which is Celsius, plus 273. And I put 273.15, they gave me it correct. They're both correct. Okay, you can put 273 or 273.15. Question 10. A fixed mass of ideal gas, okay, has volume 8 and temperature T 27. The temperature of the ideal gas is increased to 177. They kept the pressure constant, PV over T. Kept the pressure constant, so we're done with pressure. So what are we left with? V1 over T1, T1 equals V2 over T2. So can we just solve this? 8 over 27 plus 273, right? Because it has to be in Kelvin, right? Equals V2. The second volume, we don't know it. Let's just call it V2 over T2. Second temperature will be 177 plus 273. Cross multiply, you'll get 12. I won't cross multiply for you. Everyone here should know how to cross multiply. Question 11. The pressure inside the gas container is 80 centimeters of mercury. So this is pressure 1 at 127 degrees Celsius. This is T1. Temperature is dropped to minus 73, so T2. Okay, knowing that the volume of the container remains the same, the new pressure inside the container. Okay, they said the volume remains the same, so volume is constant. Volume is constant, so PV over T. What's constant? Volume. So we cover volume. So what we left with? P1 over T1, P2 over T2. Okay. Here they want the new pressure, so here they want P2. How do we find it? P1, we know P1 is 40. Okay. Remember, the units are the same, so there's no need to convert units. 40, and then T1 is 127 plus 273 equals P2, which we don't know, we're trying to find it, P2 over T2, which is minus 73 plus 273. Okay, and you get 20 when you cross multiply. Again, I will not be cross multiplying. Everyone should know how to cross multiply. Okay, 1400 centimeter cube of a gas is trapped inside a container at 15 degrees Celsius. One end of the container is closed by a movable piston with negligible friction. The gas is heated at a constant pressure, so P is constant. So PV over T, constant pressure. So what am I left with? V1 over T1 equals V2 over T2. Okay, until the volume it occupies is doubled. So the volume doubled. So what was my first volume? 1400. It doubled, so 1400 times 2. So my V2 is 2800. You just multiply by 2. What is the new temperature? So we have V1, we have T1, we have V2, we need T2. So we do V1 over T1. The first volume is 1400 over T1, which is 15 plus 273 equals where is it? V2, which is 2800. Okay, this is 1400. Close it properly. Over T2. T2 is, yeah, we're trying to find it. You cross multiply and you get 303 degrees Celsius. Oh, no, you get, sorry. You get, if I'm not wrong, you get 576. T2 is 576. 273, yeah, you get 576 Kelvin, right? We know our temperature we get is always in Kelvin, but all the choices are in Celsius. So how do you convert this Kelvin to Celsius? You subtract by 273 and you're gonna get 303. Question 13. Okay, yeah, we have to identify whether it's thermometric or not thermometric. A volume of a fixed amount of gas at a constant pressure. Okay, at a constant pressure, can you change? Okay, what characterizes a thermometric property? A thermometric property is any property that can be changed, and we said measured as well, right? So we have to see, can it be changed, can it be measured? If it can both, then it's thermometric. Let's see, volume of a fixed amount of gas at a constant pressure. Okay, if pressure is constant, PV over T, we're left with V over T. So that means, can the volume change if I change the temperature? Of course, it will be changed, right? If I change the temperature, then the volume will be changed. Okay, can I measure the volume? Of course I can. 400 centimeter cube, 1 liter, 2 decimeter cube, 1 meter cube, kaza, kaza, kaza. So you can measure it. So hence, the volume is a thermometric property. The mass of a fixed amount of gas at a constant pressure. Mass of a fixed amount of gas. It's non-thermometric. You can measure the mass, but you cannot change the mass if it's a constant pressure. You can't. The mass doesn't change. Okay, it's non-thermometric. The hardness of an egg. Remember, if you cook an egg, you change the hardness, right? But can you reverse it? No, you can't. You can't turn it back to raw. So it cannot be changed. So hence, it's not thermometric. The length of mercury in a tube, we know it's a thermometric because it goes up and down, so it changes, and it can be measured. You can just measure the length of it. Question 14. في 16 questions ولا? Okay. In order to plot a point 10 centimeters 0 degrees Celsius, where do we place it in contact with? It has to be melting ice. Remember, the 0 degrees ice point has to be melting ice. Another option was salt ice. I don't know, but they gave you other stupid options that had to do with ice. It has to be melting ice, okay, or crushed ice. How about 100 degrees Celsius? It's in contact with the steam of boiling water. There has to be the steam. Another choice was boiling water. No, boiling water will be wrong. It has to be the steam of boiling water. Or if they said above boiling water, that would also be correct. Okay, when the thermometer is 22 centimeters, how much is the temperature? Let's see, 22 centimeters is here because this is 2, 4, 6, 8, 10. So 22 would be over here. You go up. Remember, and I told you this is how you find any temperature. You take the length and then you see how much is the temperature. 60 or 60. The size of 1 degree. Okay, here's how you find the size. In case it comes, I doubt it will come, but make sure to know it. You're gonna find the length of the steam minus the length of the ice over 100. The length of the steam is 30, right? The length of the ice is 10. Divided by 100, you can get 20 over 100, which is 0.2 centimeter. But they want the answer in millimeter, so you multiply by 10, so you get 2 millimeter. Okay? Question 15. A fixed amount of gas is kept at constant temperature, 25 degrees. Okay, so since it's constant temperature, PV over T, we know constant temperature, yani P1 V1 equals P2 V2. So they gave us P1 is 1, V1 is 12, P2 is 3, find V, they want actually the temperature. Okay, yeah, just change it to Kelvin, do plus 273, okay, 298. And then they want to know which law. Akid, when temperature is constant, that means boil, right? It's boiling. So which law? Boyle's law. You could say boil or you could say boils. Both answers are correct. The final volume, now you actually apply it. So 1 times 12, P1 V1, 1 times 12 equals P2 V2, 3 times V2. So you get V2 is 4. Okay, this is self-explanatory. Question 16. Okay, initial pressure is 8 and its volume is 15. For Boyle's law to be applicable, the what must remain constant? We know temperature must remain constant. Okay, is it pressure constant also? No, it's temperature and mass. If they ever give you a second option, it should be mass. Temperature and mass must remain constant. If the volume of the gas is increased to 30, okay, what will the pressure be? So they gave us V2, okay, and they said constant temperature, PV over T. Constant temperature, yani we're using P1 V1 equals P2 V2. Boyle's law, right? P1 is 8, V1 is 15, equals P2, which is unknown. V2 is 30. You solve, you get P2 equals 4. Okay, that's it for the quiz. Hello, we'll do the grids. So we'll do the grid questions as سريع. Question 4. Describe how the ice point and steam point are located on the thermometer. Again, and I'm going to show you the solution عشان the region he likes to get, he gets them from the solution, copy paste. The point on the thermometer which corresponds to the tip of the mercury column when the thermometer is in thermal equilibrium with melting ice at a pressure of 1 atmosphere. If you see the sentence, copy paste in the exam, then you pick it, okay? But be careful for any playing with the words. If he said salt ice or above melting ice, no, that would be wrong. It has to be with melting ice or crushed ice, okay? Okay, and it has to be at a pressure of 1 atmosphere. Okay, atmospheric pressure يعني. 1 atmosphere يعني atmospheric pressure. The temperature of the thermometer when mercury level is at this point is defined to be 0 degrees Celsius. He could get which of the following is true about the ice point. Okay, and it will be 2 correct answers. The point where it's a thermal equilibrium with melting ice at a pressure of 1 atmosphere. Okay, he could get it like that. And another choice would be the temperature where it is 0 degrees Celsius. That's 2 correct answers. Steam point. Steam point is the same thing where it's thermal equilibrium with the steam above boiling water at a pressure of أكيد 1 atmosphere. And what is the temperature? 100 degrees Celsius. Question 5. Describe the working principle of a liquid in glass thermometer. Okay, how does the thermometer work? Okay, liquid in glass, any mercury or alcohol. Okay, it's thermal expansion. Okay, you have to know that the liquid expands when heated and it contracts when cooled. Okay, this wasn't in the quiz, so they could actually get it. Okay, so what principle does it use? It's the thermal expansion of substances. That could be a multiple choice. It could be what principle do liquid in glass thermometers use? And the answer will be the thermal expansion of substances. A liquid in a glass tube expands when heated and contracts when cooled. So remember, when you heat mercury, it rises and it expands, and when you cool it, it contracts and comes down. A calibrated scale can then be used to read off the respective temperature that led to the okay, blah 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 blah. هلا في 8. What is the relation between Kelvin and degrees Celsius? You should know 7. Kelvin equals degrees Celsius plus 273.15. Exactly, it would be 0.15. Okay. If they give you 2 choices and you had to choose between one or the other, and I doubt they will, you would choose 0.15 because that's the exact measurement. 9. Draw and label a thermocouple. We did this earlier. You do it like this, wire W, wire Y. This could come in the written part for physics next week. Then wire Z, okay, you would label hot junction, cold junction, galvanometer, and then you have to say W and Y are made of the same metal, Z is made out of a different metal. Okay, and then what do you say? Describe the properties of a thermocouple. Yani, what are the 3 things? Low heat capacity, okay, which makes them respond quickly. They have high precision, okay, and they are very sensitive. So what are the 3? Low heat capacity, very sensitive, high precision. Low heat capacity, high precision, very sensitive. This مثل ما هي, it can come in the written. The whole question, it can come in the written next week for the physics. I think I'm done. Yes, I'm done. Okay, like that, نكون خلصنا. Good luck. Thank you so much for watching. See you next week. Yes, see you next week for physics periodic.